You may have noticed that prior to Halloween, I was doing a bit of a series with the motorized potentiometer videos. And today is going to be ostensibly the conclusion to that series. That's right, I'm actually going to build something that uses the motorized potentiometers. But before we get on to that, yeah, let's address the elephant in the room. I changed my facial hair. I know it can be kind of jarring when your favorite YouTuber changes their appearance, but I promise that in time you'll get used to it and you won't even notice the change at all. Now, what are we going to build with a motorized potentiometer? Or multiple motorized potentiometers. I think I've already mentioned using potentiometers for audio projects several times in this series, so yeah, you guessed it, it's going to be something audio related. And I mean, do you think I just grow my hair out like this for no reason? Obviously, it's because I play electric guitar. Of course. So I'm going to build a guitar pedal, but not just any guitar pedal, a robotic guitar pedal. At least as robotic as that Gibson robot tuning guitar. You know, you throw some motors on something, you call it a robot. That's how it works, okay? So it's going to be motorized. That means you can set the knobs wherever you want without having to touch them. And I think there's a really cool practical application for this, which is that you could use it to make presets. You could take a guitar pedal with all analog circuitry, you know, how guitar players are. We don't like digital stuff, even though that's changed in the last few years, and now people use digital stuff all the time. But anyway, you got all analog circuitry, but you can go to presets, so you don't have to manually change from, you know, your light distortion tone to your heavy distortion tone, or from your, I don't know, from like your mid-scoop chugging EQ to solo boost, or something like that, you know? And I'm planning to control it with Bluetooth, so then you don't even have to bend down to move the knobs yourself. You can just do it on your phone or tablet or whatever, put that on your music stand, and adjust it. Go to presets, tweak the setting you're on currently. I think it's going to be pretty cool. And of course, I have to pick a guitar pedal to build. So I think I'm going to just go with a classic, versatile pedal, and that is the Ibanez TS9 Tube Screamer. If you've played guitar for any amount of time, I'm sure you've come across one of these. They are just used everywhere. You can get blues tones, crunchy rock tones. You can even use it as a boost to tighten up your gain on a metal amp. And famously, this thing was used by Stevie Ray Vaughan to get his signature tone. So something with a lot of versatility like that is exactly what I want because, you know, you're maybe not going to use presets that much in like a tremolo pedal. You know, I want a reason for you to set presets on this thing. And since there's such a variety of tones you can get out of this, it really fits the bill. And as you can see, I've got 3 knobs here. It's drive, tone, and level. So I'm going to need 3 motorized potentiometers to control it. This video is not really about the analog design behind this pedal, so I'm not going to go too much into the circuitry. It uses your basic op-amp diode clipping, but if you want to really dig into it and learn why this sounds the way it does, there are great resources online which I've been using to design this project. If you look up RG Keen, electrosmash.com, general guitar gadgets, any of those, plus Tube Screamer, put it in Google, and you'll find tons of stuff that'll help you understand this pedal. And your traditional Ibanez TS9 has transistor-based switching, but I'm just going to do a true bypass version, really just for the sake of simplifying the circuit. You want to have the debate about true bypass versus buffered pedals, you can do it on your own time or down in the comments. So now that we know what we're making, I think the first thing to do is just going to be to build the pedal circuit, get that working, and then we can figure out all the digital stuff after that. And I think this is a good time to mention that this video is being made in cooperation with PCBWay. PCBWay is an online service for manufacturing custom circuit boards, 3D printing, and a few other services. They offered to send me some boards and 3D prints to use in this video in exchange for a review of their service. And they didn't send me any kind of copy to read or anything like this, so this is really just my own honest review of what I got. So ordering PCBs is pretty simple. You just go to their website, configure what you want, and upload your Gerber files, and you can get a quote. Similarly, for 3D printing, you upload a CAD file and configure material options and stuff like that, and then you can order. It's pretty interesting. Their engineers actually review all of your files before they manufacture anything, and they let you know if there's going to be any problems or if you need to fix anything. And once you get the okay, then you can officially place the order, and everything will get fabricated and then be shipped. These are the boards that they sent me. Hopefully that will focus on there. I think it's pretty sharp looking. It's got my logo silk screened on right there. And as I mentioned in the motorized potentiometer part 2 video, they also 3D printed me these little hexagon tube things here, which is what I use to connect the motors to the potentiometers. And I designed these with pretty tight tolerances to fit everything together. And I'd say everything came out pretty much exactly as I wanted. I don't have any complaints. I will note that this is the first time I've ever ordered PCBs or 3D printed stuff, so I don't have a baseline to compare anything to. I will say PCBWay is a Chinese company, and there are a couple downsides there, at least if you're ordering from America. It does seem like all their work is done in their local time zone, so any correspondence that I had with the company or with customer service took about a day to complete, because I would send off an email during the day, my time, and then I wouldn't get anything back until the middle of the night when they were available. And of course, this stuff is all made to order, and it's being shipped across the globe, so don't expect Amazon Prime 2-day shipping. So I used the cheapest shipping options. I had a couple questions throughout the order process, and with all that factored in, I think the total time that includes the verification process, fabrication, and shipping took around 12 days, something like that. So like I said, I don't know how to compare that to other manufacturers, but I think that seems fair for getting something across the world. So like I mentioned, I didn't actually pay for any of this stuff, but I did get to see the totals when I ordered it. They sent me 5 of the PCBs for $1 a piece, and 10 of the little 3D printed hexagons for $24 total for those. I'd say that's a little bit more than I'd like to pay for 10 tiny little pieces like this. There were other material options, so maybe one of those would have been cheaper, but the 3D printing service doesn't have the instant quote like the PCBs do. And shipping, which again is across the whole world, would have run $20. I suspect that if you found a more local fabricator, you'd probably get a better deal on shipping, but I don't know, because electronics in general seems like an industry that just charges a ton to ship stuff. So overall, I'm very happy with how everything came out. I would not hesitate to use PCBWay again to get more stuff, so if you have any circuit board needs or 3D printing needs, check them out. In fact, I wish I'd had them print me another PCB for another part of this project, but more on that later. I'll also mention this is the first time I've ever made a PCB layout, so I use KiCad to input the schematic and turn that into a layout. So a pretty interesting learning process. Probably something I will do more in the future, because it just makes stuff so much easier once you get it all on a PCB. And as I mentioned in a previous video, this is also the first time I ever 3D modeled anything, so for that I used FreeCAD, and once again, great learning opportunity. And with that, it's been a while since I've done a soldering montage in the video, so let's get this thing put together. Alright, so I've gotten the first prototype of this stuff kind of put together, and I'm going to have to pivot. So I bought this Adafruit Itsy Bitsy Bluetooth board. It's got built-in Bluetooth and built-in memory for storage, which is important for the presets. So I thought this would be perfect. I built this awesome app, and I got the Bluetooth communication working, and I'm storing presets, but I'm running into problems. Okay, it's connected. Gonna adjust something. Not quite where it's supposed to be. And that time it just stopped. And it disconnected. Reconnect. Why? I had USB powering the chip and a separate battery powering the motors, but it seems like there's some sort of current spike or something whenever the motors come on. Well, sometimes when the motors come on, that's causing the microcontroller to reset. And you know, I could spend some time trying to add bypass caps and get the power supply more constant, but I'm not having this problem if I use the Metro Mini that I have used in a few other projects. So I think I'm just going to switch over to that, because even though I built this whole app, as I've been playing with it, I have just been thinking no one wants to have to take their hands away from the guitar in order to change something on their guitar pedal. They want to do all that with their feet. So I think scrapping Bluetooth is for the best, and instead I'm just going to go with, like a momentary contact switch that you can stomp on, and that will switch you to different presets, or you can press and hold that button, and that'll save the current preset with whatever settings you have on that pedal at that time. I think it's going to be a more solid design in the long run, but unfortunately, I'm also going to have to add an SD card reader now, because the Metro Mini doesn't have any built-in flash memory to read and write from like the Bluetooth one did. Oh, and since I'm not using an app anymore, I need to find some way on the pedal itself to tell you which preset you're on. So I'm thinking I'm just going to have an array of LEDs. I think I'll do 5 presets, so LEDs 1, 2, 3, 4, and 5. And if you go to preset 1, LED 1 lights up. You go to preset 2, LED 2 lights up. And maybe when you save, it'll blink that LED for a second so you know that you saved a preset. But I've got another problem. I'm actually using up just about every single pin on this microcontroller, so I don't have enough to add indicator pins. So what I'm going to have to do is add a shift register. So basically with a shift register, I can just use a single pin, and then I can shift out in sequence a byte. Well, that's going to be 8 zeros and ones in order, and then the shift register is going to receive those, and then it will have 8 pins on which it will send out each of those bits. So 1 pin becomes 8 pins, except it's not really 1 pin. A shift register basically uses SPI protocol, which is 3 or 4 pins. In this case, it's only going to be 3 because I don't need to send anything back from the shift register. So it's going to be an output pin, a clock pin, and a chip select pin, which is basically what enables the device. Now, I don't actually have to use up 3 new pins. I'm already using SPI for the SD card reader. So I'm going to share that clock pin and output pin, but only the chip with the chip select pin enabled is going to be the one that receives data. So I only have to use 1 new pin for a new chip select on the shift register, and then I gain 8 outputs, of which I'm only going to use 5. Okay, I've got an early prototype here. Just uses this push button here to switch through presets, and so far I've only connected up the motor for the drive knob. Got the tube screamer circuit here, push button LED, that's kind of temporary, and it's plugged in. But I do have this problem. First of all, it sounds like a tube screamer pretty much. But yeah, the problem I have is I'm powering it all from the same 9-volt input, and I'm getting some interference. So I've just muted the guitar completely, but listen to the sound when I switch presets. Yeah, so basically I think the PWM signal is bleeding through into the sound, but I think there's a pretty easy fix for it though. So I'm using this pedal power supply thing here with a bunch of different 9-volt outputs, and I'm using one of those. But I think that if I just split this so that it uses 2 inputs, one for the digital side and one for the actual tube screamer, then I think I will eliminate all of that noise stuff. So let me give it a shot. Okay, so now the motors and the microcontroller are being powered from this jack here, and this one here is powering the tube screamer itself. Okay, so let's see what we get. I'm just gonna set the drive down, and yeah, we'll cycle through some presets. Yeah, I think that resolved it. So, it's a little unfortunate that it's going to need 2 power supplies, but, isolate those and you get rid of all the noise issues and you've got a functioning guitar pedal with motors. That's what we're doing. I'm in the midst of getting this thing assembled, and currently I have, let's get some light. Currently I've got basically the tube screamer working, and the motors are not connected. None of the digital stuff is in here yet. You can see it's coming together. So I'm gonna have the main on-off switch over here, and then over here it's gonna be the tap switch for going between different presets. If I'd had any idea how complicated the digital circuit was going to become, I would have gone ahead and had a PCB made up of it too. But until then, I've got this double-decker monstrosity right here. It's all just put together with perf boards. And on the top here, I've got the microcontroller, the SD card reader, and beneath that are the motor controllers. I'm going to add some standoffs here to rigidly attach these 2 layers. And I sort of forgot about the shift register until I'd already started soldering stuff. So kind of non-traditional, but I went ahead and put it here on the underside of the top board. And I have gone ahead and tested that that's working. I've got this little array of LEDs here, and the momentary switch is working as well. Had to disassemble the tap tempo pedal that I made for my delay pedal to get that switch out. Also of note, I didn't realize this, but this is actually a normally closed switch, which means in this position, the way that I wired it up, which I did it exactly the same as the breadboard, I'm actually going to be reading a high signal, and when I push it down, that's when I'm going to read a low signal. So yeah, that's the opposite of what I planned for, but fortunately I was able to make a minor tweak to the button code to allow for normally closed switches. So it's going on 3 a.m. and I want to try to get this digital part in here, so I better get back to it. This is it fully assembled. I didn't really record too much of the actual assembly process because, I don't know, it's kind of boring. Just a bunch of trial and error trying to fit all this junk in here. As you can see, it's just a big mess of wires. But you've got the double stacked thing over here with the microcontroller and the motor controllers. All 3 motors up here. Switch circuit board is over here. And the main tube screamer circuit board is actually mounted all the way down there in the bottom, or from this side, the top. These 2 screws here holding that in place. Oh, and since there are 2 power supplies, I just use pencil for now to make a marking so I know which one's which. Got the sine wave representing the audio signal and square wave representing the digital signal over there. Yeah, I think that's about it. I'm going to put the bottom on here and do a little bit of demonstration. Just going to note that once I got everything put in the box, the PWM bleed through issue came back, even though I'm using 2 separate power supplies. So, new solution, I'm actually just going to change the frequency of the PWM signals so that they are outside of the human range of hearing, so above 20,000 hertz. And then you shouldn't hear it, even though that signal is probably still being picked up. It might annoy dogs or something, though. But I will go ahead and leave it as 2 isolated power supplies, just in case there's anything else from the digital circuit that might make its way into the audio circuit if they have a shared ground. Okay, I've got the guitar plugged in to the pedal, and then that's running into this little Fender Champ clone that I built a few years ago. That's the cabinet for it. This clone was actually one of the very first electronics projects I ever did. And then I broke it out into a head and cab instead of a single combo. And I had plans to do a few more modifications on this thing, so let me know in the comments if that's something you'd like to see in a future video. You know, some analog work on a tube amp. Oh, here's the riff from the animatronic hand video. Yeah, let's try that again. See if I can remember how to do this little tapping thing I used to play. I don't remember how it ends. Yeah, I think that pretty much demonstrates what it can do. You know, you switch between stuff. I mean, I can do one more dramatic preset change so that everyone can definitely tell it's doing something. So currently, setting 1 is all in the middle, so I'll just change that up and save it, and we'll try it again. Okay. Now we got a bright, clean tone, just a little bit of dirt. We'll go back around. And we're back to our bright, clean tone. So that's about it. As usual, I'm not building this to be like a commercially available product or something like that. I'm just building something that's, you know, a cool proof of concept and something fun for me to play with. But it does have its own problems. I mean, for one thing, the power supply I'm using is only supposed to output up to 500 milliamps, and I'm pretty sure that using these motors, even though I have them working in sequence instead of all at one time, that's still probably causing giant current spikes every time a motor starts up or changes directions or something like that. So I'm definitely not powering this thing perfectly, evidenced by the fact that occasionally it will still restart the microcontroller. The Metro Mini was a little bit more resilient against the power demands of this thing, but now that I'm using one power supply to power the motors and the microcontroller, and I'm getting these big current spikes, occasionally it will still power cycle that microcontroller. And you may have noticed during the demo that occasionally the LEDs just sort of go crazy and they do not display what they're supposed to be displaying. And I'm pretty sure that's also caused by this current spike. I think that when a motor starts going, it's causing the voltage to dip on some of the output pins on the microcontroller, including the one that controls the shift register, which means it thinks it needs to receive new data, and then it just screws everything up until the next time you change preset. And these cheap little motors I'm using, they just do not have the torque to turn these knobs at low speeds. To make everything move more smoothly, I didn't even use gears. I just connected the motors directly to the pots this time. So that's an even greater load on each motor. But essentially, because you don't have enough torque, you can't make fine movements to get exactly where you want to be. So you lose a little bit of accuracy. And that's everything. This thing took way longer than I expected. It was a much more complicated project than I initially set out to complete. But in the end, it was a very fun thing to do. I actually have had this project in mind for years. I did something kind of similar in college, but not using motorized stuff, just using digital potentiometers. And since then, I've wanted to build a configurable analog guitar pedal. So yeah, I finally sat down and faced some of the challenges that brings. And if you're thinking, well, why didn't you just use digital pots? And then you didn't have to deal with all this, high current and torque stuff that's getting in the way. Well, the problem with digital pots is they don't have any sort of knob, so you'd still have to put something on there so that, you still have the ability to just bend down and control your pedal without having some sort of digital interface. So that's part of why I went this route, and the other reason is it's just cool to make stuff mechanical and robotic, and move on its own. It's fun. So if you got anything out of this video, let me know what it was down in the comments. Like, subscribe if you feel like it, and that's about it.